Oke, ini kalau kita satu di management masalah Abbad with NRP 0x7. So today I will describe or I will present my answer for the question 3.12 and 2.13. So the first one is 3.12. So this question is the vendor offer functionally identical product. The expected lifetime of both the product is 10 months. So this means that this 10 months is the new. So the new is 10 months. However, the distribution of the first is exponential, while the other is along with parameter 2 and 0. If the aim is to maximize the probability that the lifetime of the product is greater than 8 months, which of the two products should be chosen? So the first step is we want to calculate the lambda for every distribution. Or we can calculate the probability of x is greater than 1 for the two product. So for the first product, we can call it x with the distribution of exponential with parameter lambda. So we have q here, which is expectation of x, which is 1 per lambda is equal to 10. So we can calculate the lambda is 1 after 10. So we get that lambda is 0.1. And then we can calculate also the probability of the product will be the lifetime will be greater than months. So the probability of the product lifetime is greater than month is 1 minus probability that the product will be lifetime will be less than or equal to month. So this is because that this equation can be written to 1 minus a exponential of minus lambda 8. So we get the lambda is 0.1. So we can get this exponential of the minus 0. And we get that the first product is the probability that the lifetime is greater than 8 months is 0.449. And the second product, we get that we can call it y. So y is the exponential of lambda with parameter 2 and mu. So we have that the mu in the first is 10. So mu is also exponential of y, which is k per lambda 10. And the k in there is 2. So that 2 per lambda equals to 10. So that lambda equals to 0.2 because 2 after that, we can also calculate the probability that the lifetime is greater than 8, which is 1 minus the probability that the lifetime is less than or equal to 8 for the Erlang distribution, which is 1 minus 1 minus a exponential of in the 8 also, but it has the value of 1 plus lambda. So that with the question, we get that probability is a exponential of minus. So we get that lambda is 0.2, so 0.2 times 8 times 1 plus 0.2 times 8. So this we can calculate this. We get that the probability of the lifetime of the second product equal greater than 8 months is 0.55. So we can see that the lifetime of the second product, the probability that the lifetime of the second product greater than 6 months is greater than the first product. So we can use the second product because the probability is higher. probability y greater than 8 is greater than probability of x greater than 8. So we can use second one because it has the greater. And for the next question is 3.13. This is the question. So the lifetime of an item is an exponential random variable with mean 5 days. We replace this item upon failure or at the end of the fourth day. So again, we have the mean, which is mu is 5, and we replace this item upon failure or at the end of the fourth day. So we want to know the maximum or the minimum of the failure, which is 4 day or greater than 4 day. This occur first. So we need to compute the expected time of replacement. So in here, if it's an exponential variable, we can calculate the lambda, so exponential of x, which is lambda is 5. So lambda is 1.5, which is 0.2. And one, we have the two cases in this question. This case one is when the item, the failure is at the within 4 days. So the probability of the x is less than or equal to 4. And the case two is when the probability that the x is greater than 4. So in the first case, we will we will replace the item before the fourth day. If the second case, we will replace the item at the fourth day because the failure is greater than fourth day. So we can compute the expected time of replacement by exponential of the minimum of x and 4. So this means that we need to calculate the expected time of replacement with minimum of 4 and x, which is x is greater than 4. So we can calculate this by integral of 0 to 4 x times x dx plus 4 times probability of x greater than 4. So we can calculate this. We know that the x of the exponential distribution is lambda a pangkat minus lambda x. So we have the lambda 0.2. So 0.2 a exponential minus x. So we can calculate the integral 0 to 4 x times 0.2 exponential of 0.2 x dx plus 4 times. So the probability of x greater than 4 is exponential of minus lambda. Lambda is lambda. For the lambda is 0. We can calculate this at the first number of the or the 3.12, which is 1 minus 1 minus so this is 1 minus the x lower than or equal. So we can calculate this expression into the probability of or the expected time of replacement. We get that the value if is the first one is 0.9 and the second one is 1.7. So we get that expected time of replacement is 2.6. Okay, that's all for me. Thank you for the attention. Assalamualaikum warahmatullahi wabarakatuh.